Welcome 6th graders. Today we're going to be continuing our work with proportions, and we're also going to be looking at equations. By the end of this lesson you want to be able to write an equation for proportional relationships. So first what I want you to do is pause the video and read through these questions and try to figure them out on your own and see how you do. The table at the right shows the amount of money my niece earns based on the number of hours that she babysits Josh. So I want you to go ahead and answer those questions based on that table and then check your answers. What relationship do you see between the number of hours she babysits and her earnings? Okay, I want you to think about that. So if I look, I'm looking at the hours and her earnings. So for 1 hour, she earned $5. For 2, 10, okay, 3, 15, and so forth. Well, if I start to look at that, it looks like her earnings are equal to $5 times the number of hours. Do you think this relationship is proportional? Why or why not? Hope you said yes, because if you look at it, each of these would simplify to the same fraction. So we'd have $5 for 1 hour, 10 over 2, 15 for 3, and all of them actually simplify to that 5 for 1. So what rule could I use to find the amount of money my niece earns for H hours? So if H is my number of hours, we could say that she earns $5 per hour, or write it as 5 times H, kind of like what we were doing with the sequences. And if E represents the amount my niece earns, what equation could I use to represent the situation? So her earnings would equal $5 times the number of hours, which actually kind of leads up to what I had said originally in number 1. Alright, so let's look at another situation. The presentation basketball team is holding a car wash to raise money for new equipment. They are charging $7 for each car that they wash. So why don't you go ahead and pause the video and try to answer these next 3 questions on your own. So first we're going to make a table to show the relationship between the number of cars washed, C, and the total amount earned, T. So we have cars washed and T amount earned. So if they're charging $7 for each car that they washed, if they washed 1 car, they would have earned $7. 2 cars would be 14, 3 cars 21, 4 cars 28. So we can say that for C, cars washed, it's 7. Let's just hold on for that for now, right now. So it's going to be 1 car washed earns $7. So for writing an equation to, this should be find the total amount of earnings T for washing cars, the total amount we're earning is equal to $7 times the number of cars that we washed. So if the team washed 25 cars, how much money did they make? So we would have T equals 7 times 25, and if I think like quarters, if I have 7 quarters, 4 makes $1, I have 3 left over. So that would make $175 that they earned. The general admission to a local fair is shown in the table at the right. We want to write a sentence and an equation to describe how the total admission T is related to the number of people N. Then I want you to find the total admission charge for a group of 8 people. So go ahead and pause the video and see if you can figure this one out on your own. I would start by looking at the relationship between the number of people and the total admission. So if I look at each of these, 3 to 12, 4 to 16, 5 to 20, 6 to 24, I can start with that original proportion again. So $12 for 3 people, $16 for 4, $20 for 5. If I simplify all these, 12 divided by 3 is 4, 16 divided by 4 is 4, 20 divided by 5 is 4. I notice that they share, that they all simplify to the same proportion, which would be $4 for 1 person. So my sentence would be, it costs $4 per person. And my equation could be that the total admission, T, is equal to 4 times the number of people, which they said was N. So if I want to find the admission charge for 8 people, my total admission is going to equal 4 times the number of people, which in this case is 8. So the total admission here would be $32. Don't forget to leave a question on Edmodo if you have one. And we will continue discussing this tomorrow.